Oh, that's
Yeah.
nice. In class on Friday, I thought you said that 2.5 would be due on Wednesday. We could do it on Tuesday. Since we have 2.4 due today. And
We didn't finish 2.5 yet. Yeah. Sorry.
you
Say
have
that.
it due to tonight. I thought
Oh, you
said
do? Okay. I will change it up.
Yeah.
Yeah, I'll change it up.
Okay.
So 2.4 should be due tonight. 2.5 will be due on Wednesday. We'll finish up 2.5 lecture today. We've got just a couple more to do. Second of all is, then we'll review, and then test on Monday of this week. And then about half an hour ago, you guys should have received an email from me. And it has this little stuff right here. It's the study guide for the chapter 2 exam.
That's lovely. I like
It is going to have 20 questions on it right there. And
20 questions.
and everything that we've covered so far. So you should see it in the email. If you have any questions, please bring it on Wednesday. We good? As you see it here, but stuff that we covered. 2.1 was, can you change from one form to another? That's what this one was. Can you, just given a vertex and another graph at point it passes, can you write the equation? Can you graph the quadratic equation from standard form? Then we have long division, synthetic division. We have the factor theorem. And then remember all those complex numbers we talked about, right? Can we write it, add, subtract, multiply, divide, and then stuff we're working on right now, which is the set of all possible rational numbers. Just give it to me. Just give all the different possible rational numbers that could it be. And then we'll make this distinction today is what are rational zeros and all the zeros. Right, rational zeros only include fractions and integers. All zeros will include
20 questions on the test.
20 questions, yeah.
Okay,
Cool.
that's not awful.
Hey, it's like
No, no.
20 questions. You just repeat it wrong.
No, this is
Huh?
really 20 questions.
Dylan, question.
So are the questions going to be based off of the number next to the? what is
Yeah,
the
so
number?
these are, so there's question number 12 and 13 is going to have this one.
Oh, okay, so it's not like from the book, that's the question. It's just-
No, this is my numbering of the test questions.
And it's gonna align exactly like that. on the
So
test.
find the,
Because that means I know
So
what to
it's not
study
saying
and how much to
12 on
study.
the book is around, it's saying that just number 12 on
That's
the
what a
test.
study guide's for.
yeah, correct,
And then also, are we doing a separate test for 3.6, 3.7?
correct, yeah, because I know all algebra textbooks, they kind of stick those at the end of this, but they really are separate ideas. They're different
So
ideas
that
there.
test is not gonna be very long.
No, probably be still about 15, 20 questions-ish.
Wait,
Yeah,
it's on
'cause
Wednesday or Friday?
it'll be Monday of next week, so a
Oh,
week from today.
Holy.
Oh, if I have questions from 2.4, we do have to.
Yeah, absolutely. We'll do those and we'll finish up 2.5. So let's jump to lecture here. So if you have, let's jam with questions from homework questions from 2.4, so you guys can turn in the homework. And then we'll do 2.5, the rest of it. So homework questions 2.4, so we can turn them in, all yours. Give me a list of numbers if you have them. Go ahead, Abe.
Well, there's a lot of like the big fraction ones that I didn't get, but those are more like math errors. Like, I was confused when it was the larger exponents on the i's and then how you simplify them.
Oh, gotcha. Okay. Let me see where those are at.
I think it was like 75, 77, and 79.
Gotcha. Okay. All right, let's talk about those here because I was thinking of skipping that piece here, but let's do those. Quick lecture on higher orders. So talk to me here. You guys are okay with this one right here? I by definition is a square root of -1. So let's do a quick finishing up lecture of 2.4. I squared, when you square it, becomes this right over here. Every good there. So now the question is, what happens if you go I to the third power, I to the fourth power, I to the fifth power, and so on? So these are called higher order powers of I. So this one if we think about powers, we think about, okay, hold on. Remember in algebra class, remember how we had this little guy right here? It says a to the m multiplied by a to the n gets you a to the n plus n, right? Whenever you multiply numbers, all you really got to do is just add the exponents. And so with this one, if you have I to the third power, that is really just I to the second power times I to the first. Agreed?
Just -1 I.
Yeah, which is just -1 times I, which is -I. Oh, okay, so check mark that off the list. And then I to the fourth. Well, let's see. Maybe it's be easiest just to use I to the second, because I to the second is a -1, and that simplifies easily. We good? So I to the fourth is really just I to the second times another I to the second.
This is one thing is -1.
Oh, that is weird. Look at that. I to the fourth actually just becomes 1.
And it's just alternate, so the odds is negative I and the evens are negative,
Close, Abe. It's doesn't alternate between even and odd. It alternates every 4. So notice that we get a 1. Once you get a 1 in a cycle, that means the cycle is going to start now over again. So if you have I to the fourth times I, now instead of using I to the second, I'm going to use I to the fourth now, because that's an easier one, because that's just 1 now. So I to the fifth is really just I to the fourth times 1, or just I. I to the sixth is really just I to the fourth times I squared, which is really just 1 times -1. I to the seventh is really I to the fourth times I to the third, which is really just 1 times -I, or just -I. Okay, then you guys talk to me. What is I to the eighth then?
1.
Just a 1. It's I to the fourth and another I to the fourth.
So it's I, -1, I.
So let's do the list here. Do list. If you, just in case you get I to the 0 would just be 1. True? Because any number to the 0 power is 1. I to the 1 power is just going to be I. I to the second power is going to be -1. I to the third power is -I. I to the fourth power back to 1. So notice it cycles like this. So if you go I to the fifth, it's just going to cycle back now. So back to I to the sixth, -1, I to the seventh, I to the eighth, just 1. I think that's the highest it goes on the homework here. It goes I to the sixth is the highest. So there's your little group here. Cool. Let's see. Let's do this here. Kind of fun. These guys are called cyclic numbers. Because they cycle back, right? So give me a number that is cyclic. Let's see, how do you call it here? Cyclic with always repeating itself.
So it only has like 1 cycle.
Just 1 cycle. 1 does it, right? 1 squared, 1 cubed, 1 to the fourth. Boom. Any other number. Cyclic number with a cycle of 1. 0. Absolutely. Those are the 2 numbers that cycle. So how about a number with a cycle of 2? -1. Absolutely. There it is. And then a number with a cycle of 4. It's I. That's it. And that's the only ones that cycle. Beyond that, we have things that explode, right? Because 2 to the fourth, 2 to the fifth, to the fifth, it's going to go up like crazy, right? Any things that are between 1 and 0, they're going to go down because they're fractions of something. So you get fraction of a fraction of a fraction of a fraction forever going down. But those are the only numbers that cycle, which is kind of interesting, the way it does that. And so then you have, you can go into a whole bunch of fun stuff here. So then how fast do prime numbers cycle? And then you have those kinds. So it's not just a number, it's just the numbers themselves. And you go on through a whole entire fun loop there. Okay, 2.4. Any other questions off homework or any type of concept questions from 2.4? You guys okay with homework? Raise your hand if you're done with homework for 2.4. Done, okay. 2.4 pretty easy with the complex numbers. Thought it was a little bit easier than most things in class, maybe, sort of. Okay, so let's jam. Let's see where we're at in chapter 2.5. 2.5 was this right here. It says find all the zeros. And so let's kind of think back to what we did here. We did our P and our Q. We wrote it as fractions and we started guessing. That's what we started doing. For example, 1. And then we got ourselves. Now these guys, notice these guys are rational answers. Is that right? Rational means it's an integer or a fraction. On example 2, when we did our P's and Q's. We had a little bit of a tough time finding the one that works. With a little bit of help, we found 2/3 that worked. We checked it to make sure that it has a remainder of 0. We got the rest of it. And then at that point, we had to use quadratic formula. Question, is this guy a rational answer? No, it's not a fraction. It's not an integer. Right? So if I were to say, find the rational zeros, you would have only given me this answer. We good? If I say find all the zeros, then you would have given me all those answers. Okay, so what do we notice here? We notice here that when we do the quadratic formula is always going to give us a plus and minus. So if it is a irrational answer, which means it has a square root in it, or it has an I next to it, you know it has to have a plus and a minus, because that's the way it flows out of the quadratic formula each and every single time. We good? Okay, so example 3, let's jam to example 3 then. Dun, 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 dun. This is cool stuff. Jump to this here. The reason why we take such a long time to do these polynomial functions is because polynomials are so versatile. Let's say you had a, just real quick here, let's say you had a stock market and it went up like this, then it went down, then it went up a little bit more, then it went down a little bit like this. Any dots that I can create on a board, I can connect them through by a polynomial. So polynomials are just so fascinating ways that we can actually produce models of things. So this polynomial function, I can create a model. I can go up like this, I go down, and each one becomes my, I can just turn it really fast. Notice, and I'm modeling all those, the highs and lows become my models. And so polynomial functions used quite a bit in order to do that. Let's see, I think we have some time here. So find, let's go with, this little function. Find, ready, all rational zeros on this one. And I got my little, zoom in feature now. Da, 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 da.
But what side's P and Q again?
P is wait, is P the one on the top?
P is the one on the
Yeah,
top.
That's the
Yeah.
last number.
Last number.
Q is the coefficient of the lead.
Awesome. Okay. Perfect. So this guy here. Oh. Yep. So factors of the guy in the back are P. Factors of the number in front is Q.
P over P.
And we go for it here. So P, factors of P would be plus or minus 1, plus or minus 2, plus or minus what, 4, is that right? Plus or minus 8. All right, and I do not know the answer to this one here, so Q, and let's see again, your book writes it as capital letters or lowercase letters?
Capital P and lowercase. Yeah.
Mm-hmm. Yeah, lowercase, okay. Plus or minus 1, plus or minus 3. So P over Q. P is kind of funny, correct? Because it looks like could be a capital, could not be a capital, right? So all yours to at least write down your possible. So on the test, I will have something called write down the possible rational zeros. And so possible rational zeros are all the ways you can write down P over Q. Okay. All right, so I'm going to go for that. So Q being a 1, what it's going to do is just going to allow us to write all the P values. And then P being 3, ooh, 3 does not reduce any time, huh? So it's just going to be 1/3, 2/3, 4/3, 8/3. Whew, there's your all possible rational zeros. They're possibilities, they're not true, not for sure. Yeah, 1/3, 2/3, 4/3, and then 8/3. All right, then goes the guess and the check, huh? This is not the fun part.
I've done 1 and -1. I don't think it's probably 2.
Okay.
Why don't you know negative?
Yeah, 1 and 2.
Okay, so one and -1 go away. 2 and -2 go away. Should we divvy up the work here, guys?
I'll take the 4s.
So Isabel 4 and -4.
Yeah.
Annette, if you can do 8. Landon, which one you're doing?
I'm doing -8.
-8, cool. Dylan, can you do positive 1/3?
Sure.
Tristan, negative 1/3. Maddie, positive 2/3. Camille, negative 2/3. When you finish up with the history homework. Charlie, 4/3.
But
Negative 4/3, Owen.
Yeah.
And positive 8/3. Abe, and negative 8/3, Dylan.
Wait.
Maddie, which one do you have? It's 2/3. Okay, I'm gonna try negative 2/3. How about Camille, you know?
According to my calculations, it is not 1/3.
It's what one?
It is not 1/3.
Not 1/3. Not negative 1/3 either?
it's not possible.
4 ninths plus a negative 16/3 plus 8.
Yeah, it's definitely not -8.
Okay, negative 8/9 minus 16/9 plus, oh, minus 16/3. Make sure I got that right. Multiply by 3, that makes 48 over 9. 72, let's see.
Yeah, it's none of the boys.
None of the 4s, okay?
Well, do you know that or wonder?
We did positive 8.
I think you did that right.
No, I did.
You did
positive 8.
No.
Someone, anyone?
Can we use a calculator?
No.
My equation is very large.
Mm-hmm.
I don't think it's mine.
Yes, I'll do
Let's see, I got
Oh, do you
14.
have a calculator?
Oh, you know what? Let's see, that's 14,
They're not keeping up.
4, 5, 6.
When you're away from school, right?
Yeah.
Well, there's your answer. Such a long literally happened.
60 should be 70.
Shut the fuck up.
Not negative 8/3. Not negative 8/3 either.
I don't think it's positive. I could be wrong. Oh, is it positive 8/3?
I don't know.
Well, it's not positive 8 either, so it's none of the 8s.
Not positive, low green.
Okay, so we're stuckies a little bit here. So I'm gonna go like this then. I'm gonna go to,
Which one's?
which one have we done?
Well, you can check out the 8s
And the four.
and the 4s. And the 8/3.
4/3. Charlie, you didn't get it either, right? Okay,
I don't think it's
Owen.
positive.
Owen has a way done less. Go ahead.
Well, I just got half the terms to cancel each other.
Okay,
So we'll do that first.
that's a good thing.
With which number?
No, never mind. Can somebody do 288 divided by 27?
Anyway, two.
I don't think it's long
division.
Yeah,
do long division. That's not possible.
1,560.
288 divided by 27.
That's right.
Over
Uh-huh.
27.
10.66, repeating,
Uh-huh.
There we go.
which is 10 and 2/3.
You get
Not
the
gonna
same
happen,
rate,
okay.
so it's the- Oh, yeah, you're using a calculator.
Okay,
Not
well,
cheating.
it's not negative
You're
4/3.
resourceful.
I got excited,
Okay.
I got the first two terms to cancel, and I was like.
You're welcome, I just
don't
ever want to agree with him, so, yeah, okay.
That's weird, because usually when 2 terms cancel, the other ones should cancel as well, but let's see.
Feelings mutual.
So we are stuck, guys. What should we do? What should we do? Yeah, someone calculated something wrong. So what are we trying to find? We're trying to find where this graph, technically it's a graph, right? And the zeros are what?
Hey, wait a minute. What if the graph never touches the x-axis?
Oh, hold on, yeah, so these zeros are really just where a graph touches an x-axis, right? Okay.
They're all invisible.
So hold on, so really,
I got so excited.
Now I'm glad that I'm doing your Latin homework.
so really what happens is we're just trying to find, let me move this over here real quick.
No. you
I'm
guys
gonna
are
go
doing
to-
it So wrong, you literally just take the 0, write it down, bingo, you got your.
And we're gonna have to go to get a calculator, but what we need a calculator for is just to see maybe possibly it gets close to our graph. So I'm gonna go to Desmos,
That's dumb.
just to get a little graph here. 3x to the third, is that right?
Yep. Minus 4x squared.
Thank you, minus 4x squared. What else?
Plus 8x.
Plus 8x
Plus 8.
plus 8. Ooh,
So we did
okay.
something wrong. Okay.
Oh, there is a 0. There's only one 0 here.
But that very much does.
That looks like.
But notice-
It's negative.
Yeah, it's negative. Notice also it's a, real quick
Very
here.
small fraction.
It's x to the third. Our polynomial is x to the third, right? we only have one. We call it a real zero, a rational zero, right? So
Doesn't it usually like cross twice or 3 times? When that's number?
Why is the number still, what?
that's
what's the line?
huge.
It's still there, it's just, it's almost the same as the y-axis.
Zooming in, zooming in.
The line.
All right, so this is 1, -1. So it's less than negative.
Interesting.
It does look kind of like negative two.
It is exactly.
Yeah.
Hold on,
That's
Any-
negative 2/3.
Anybody check -2/3? Oh, that's Camille's.
I didn't do that one, you did that one, so. Didn't I say it was gonna be mine at one point in time? Or did I just think that and forget to stop for once?
So that's -24.
I don't know.
Yeah, let's see, that's -24. -24 plus 40 is -72/9 plus 8, which is 0. We got our answer, -2/3. Okay, notice the connection though. We see it on the graph as well. That looked like -2/3, right? We did the math behind it. It gives us the 0. And so let's go a little bit more. Even though it says this, find all the rational zeros. So if there were any other zeros, we would have had 2 more people say some answers as well, right? We good? Because there would have been 2 or at least 2 more people, right? Or no, at most 2 more people. But we didn't. We only had 1 single answer. The graph sort of shows it as well. But let's see what we're left with afterwards.
Can you explain at the bottom if you got the 2/3 to 0?
Oh, sure. Let's see. It's plugged in the 2/3, makes -8/27. And I cross out the 3 and the 27 makes a 9. Everybody good there?
Oh, right.
Oh,
Don't factor things in.
Right, the cube is here.
Oh, you don't multiply the denominator and numerator by 3, you just do the.
Yeah, because it's a multiplier. Technically, you're multiplying by 3/1.
Oh, okay.
So you're canceling your denominator, or reducing it at least. So -8. Then I have myself 4s don't cancel because they're top and bottom, so that makes a -16. 8 times -2 is -16/3, but then I need to make it a denominator of 9. So I'm going to multiply by 3, makes 48. And 24 plus, so it's -8/9, -16/9, -48/9. Makes -72/9 plus 8 is 0. Are we good? Okay, so let's do this here. Let's keep on going. Understanding that the graph already told us we don't have any more real zeros, we don't have any more rational zeros. So let's see what happens here. And then we'll do another kind here. So -2/3 is the answer. -2/3 goes out in front. Scoot this away. And we get ourselves our synthetic division. So 3, -4, 8, and 8. Go ahead, Abe.
No.
I bring down the 3 and I multiply back up. -2, yeah, -2. And if you need to do it off to the side, that's fine. Just gonna go like this, or 3/1, 3 is gone. That's -6. -2/3 times -6. 1, 2. Is that 4? Is that right?
Yeah.
4 goes up. And -2/3 times 4. Oh, 12, sorry, 12. 12 comes down, sorry. That's gonna be 4, which is -8, which is 0. Cool. Our remainder, or our polynomial that's left over,
3x² - 6x.
Okay, we can set this guy equal to 0 because we're just trying to find more zeros, right? We found negative 2/3. That's great. So this one, 3, 6, and 12. I think I can factor out a 3. Is that right? Or I can divide everything by 3. So notice what I'm going to do. I'm going to divide everything here by 3. I'm able to do it because I have an equal sign. So x squared minus 2x plus 4.
Or you can just divide, you don't have to factor it out.
You can divide it, yeah. So if you were factoring, you factor the 3, but since you're solving for an equation, you can divide it out. Okay, x squared minus 2x plus 4. Can I factor this guy down?
Actually, no.
4, 4, 2, 2.
If you quadratic.
Yeah, so here's the quadratic formula. Quadratic formula, let's talk about this here, could give us a real answer. It also can give us a complex answer. We good? It can kind of go 2 different directions. And so we have to be kind of careful when we do that here. So let's go for it here though. X is equal to negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 4
Isn't it
over.
just positive 2 because it's negative 3 and b is negative 2?
Sorry, yep. So that's going to be 4, that's going to be 16.
That gives you a negative inside the radical, so that's not gonna be part of our answer.
Perfect. Okay, that's what I want to get to here. And so we get ourselves, once you get to this little step right here, you see this little negative inside the radical. You know that you're not going to have any rational numbers anymore, right? You know you're not going to have any real numbers anymore. And so you could stop there. But if I were to say find all the zeros, we're good? If I said find all the zeros, you would still have to continue. We're good? Just kind of depends what you're trying to find. And so if you're talking about a real object, the width of a building or something else like that, you're going to have to get real numbers. And so in mathematics, this is what Dr. Cardano was we're really kind of thinking and pondering, right? Because that is not a real number anymore. It doesn't belong to any shape. We're good. And so then mathematicians dismissed it all the way from Al-Khwarizmi, who invented algebra, all the way to Dr. Cardano. And then Dr. Cardano decided, I'm going to just label it. So there it is. Okay. And then one last one, part of the homework here section. Example 3, example 4. So find all the zeros given a 0. So we know one answer already out of this bunch. We're going to try to get the other ones here. I think we might need 2 of them. Let's see. So x cubed plus x squared plus 9x plus 9. Great. And then here it is. I'm given a 0. 3i is actually a 0. Yeah, we know 3i is a 0. So x is equal to 3i would be a 0.
We can just go straight to synthetic.
To where?
We go straight to synthetic division.
I wish we could.
Oh, there's 3. That's not really annoying.
Oh, yes, there's our problem. So just to catch up, Owen. Owen, we need to find all the zeros of this polynomial, and we're given us a 0. And we're given 3i to be one of those zeros. And so it's almost like, have you guys ever solved a puzzle? One of those little word puzzles, right? Where you know a little bit of the puzzle, right? And then what you have to do is you have to sort of make that little section first, and then you can go on to another section, and once those, then you can join the 2 big sections together. We're kind of doing that. So we have all our tools at our disposal. Tools are rational zeros, right? Possible rational zero. We have long division, synthetic division. We have this whole idea of 3i. Anytime you have an I, you know it came in pairs. We're good? You know, there's some pairs that came in.
How do we get 3i as 0?
Ah, I gave it to you.
Oh, you gave it
Yeah,
to us,
uh-huh.
so that is one of the zeros.
Yeah, for sure you know it.
That's what I expected.
Wait, so I did like the guessing zero thing then.
Ah, good, good, good. That's cool. It was supposed to be an easy one here. You're not supposed to go that direction because it gets more complicated, but it's an easy one. Yeah, -1 would work. Let's see how we get to that -1. So first things first, I have a 3i. If I have a 3i, I know what other answer do I have already? -3i. So this guy lends me to know that I have also this answer. Okay, if 3i is an answer, x is equal to 3i is how the solution set goes. And x is equal to -3i is how the solution set goes. Are we good there so far?
How do we know that we have a -3i?
Because whenever we do the quadratic formula, we have the little plus and minus in front of the square root all the time. Okay, so let's do this here. We're going to work backwards for a little bit. We're good? Let's work backwards. We're going to go -3i, x minus 3i equals 0 over here, and x plus 3i gives me the 0 over here. And if two numbers are equal to 0, that means if we multiply them together, it would also give me a 0. And what is that when you multiply those guys together? So this would be x squared. That would be a plus 3ix minus 3x. Those will cancel. And what is that?
9i squared.
Minus 9i squared, which technically would be plus 9. That's cool. Okay, I got a little bit of the puzzle. We good? There's my extra puzzle. I like it so far. Oh, you know what we can do now? Shucks. We can't do synthetic division because that's not a linear form. If it was x plus 9, then we could have done synthetic division. X squared plus 9 means we have to do long division on our hands. So that's why we learn long division, because sometimes you can use synthetic division. So let's use long division on this guy, because once we divide this out, we should be able to see what's left over. We good? And so we go x squared plus 9, and this is a little tiny bit more complicated long division than we were used to here, but that's okay. Okay, we got our columns, is that right? Columns are set, boom, boom, boom. So question is, what multiplies x squared to give you x cubed? X is right, we have to put it into the x column. Let me do it this way here. X times x squared gives me x cubed. X times 9 plus 9x, and then we subtract, is that right? Instead of subtracting, we just change the signs and we can add down because it's much easier to do that. Oh, how cool. Okay, so x cubes are gone. Hey, the 9x and minus 9x are gone.
Just for clarification, why do you start at 9x again instead of x squared?
Oh, I did it here first, but these are my columns. This is my x cubed column, x squared column. So if I need to multiply by x, it has to go in this column. Good there, Dylan? Awesome. This becomes 0, that becomes 0. Nice. What gets to come down? X squared, plus, whoa, plus 9, perfect. Okay, what multiplies x squared to give you an x squared? A positive 1, and now it's a constant, so it has to belong in the constant column. So I have 1 times x squared is x squared, 1 times 9 is 9, we subtract. In this case, you can see what's going to happen even if we put in negatives there, voila, we get ourselves, dun, 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 Done. Are we good? Okay. Hold on. Oh, so hold on. That is a polynomial that's left over, right? So if I'm going to solve it for 0, I'm going to have to say x plus 1 equals 0. And it's negative 1. Are we good? Okay, question is, have I found all my zeros now?
You know that the x squared plus 9 is just the 3i.
Yeah, there's my first 0, right? There's my second 0. And by doing this long division stuff, I found my third 0. And I know that's all because I have an x cubed polynomial. So I'm done. Here it is. My zeros are 3i, negative 3i, negative 1. Works, and A was correct. It was negative 1. Okay, a little more complicated one. We're good? Okay, so real quick here, does that make sense? We knew 1. We kind of had to do a little bit of work with that 1. Couldn't use synthetic division. We had to use long division, and we were able to get the other ones here. Dylan, question, go.
So, like, obviously there's that square plus 9, but what really is that piece of information? Because you just got it from 3i, like, what does that piece of information mean?
This piece of right here?
Like, that square plus 9, like, I know that, like, why can we get that from the 3i?
Say again, just one more time. Just make sure
Where did the x squared plus 9 come from? Like, obviously it comes from the 3i, but like, how does that tie into the problem?
this guy over here?
Yes.
Oh, yes, Since we know that this right here is made from zeros, we know that this guy can divide the original equation.
So it's just you simplified the 3i and got that basically? Okay.
Multiplied it out, technically,
And then since you knew that was equal to 0, you could find the last part.
And I had to have a remainder of 0 because I found out that, let's write the next slide. I know that this is the case. I know that this now is factorable by x squared plus 9 times something else. And I found that something else to be x plus 1. Cool. So yeah, it's almost like these little puzzle pieces we get to put together here. Okay, and example 5, let's jam. Let's see if we can get there. Same exact type of problem here. Yeah, let's do it. Okay. Okay, so 3x cubed minus 4x squared plus 8x plus 8. I like 8s today for some reason. 1 minus the cube root square root of 3i.
We use this problem already? But I'm sure everyone
Did we have this problem already?
Yeah.
Let's see, out of curiosity here. How fun. We did.
Wait a second. Well, that means we already know.
Yeah, so what's the answer that we got?
This was like a really long.
Oh, yeah, before we were trying to find a rational.
Like a negative 2/3.
Yeah, it was negative 2/3.
Negative 2/3. Okay, so at the end we should get a negative 2/3 for the answer somewhere here, right? So let's go for it here. So we got 1 minus the square root of 3i is one answer.
Use 1 plus.
Then we know the other one has to be 1 plus the square root of 3i is the other answer. So then, and
That's the only 0.
yeah, then we're trying to find the last one here. So.
Oh, right.
So let's do this here. Some books like to write the I in back of the square root. I like to write it in the front because then I know exactly where it is. It's right there. And then this one's going to give me 1 plus I root 3. Just depends because it's the square root anyways. Just depends where you want to write it. So with a few minutes remaining, let's jam. So I'm going to subtract 1 from this side. I'm going to add I root 3 to give me a 0. True? Okay, so don't get lost in the math here because this is where we can get lost. This one's going to be subtracting 1, subtracting I root 3 to give me 0. Weird, crazy stuff. Now I'm gonna have to multiply these guys together. It's gonna be a long multiplication. Let's see where we're at. This is gonna be x minus 1 plus I root 3, x minus 1 minus I root 3.
Oh, no.
That has to be multiplied together.
Oh, you're so mean.
It's not me, it's the book.
No.
X times x is x squared minus x. Oh man, this is gonna be a minus x I root 3. Phew, okay. So let's go next one here. This is -1 makes negative x. -1 times -1 makes a positive 1. And -1 times all that makes a positive all that. Okay, good. On the last multiplication, it's kind of a little bit easier because we can actually list them underneath each other. So check this out. So this one right here, as you multiply this together, it's going to be xi root 3. So you can put that where you want it. I would write it underneath here. It's going to be xi root 3 because you know things are going to cancel. Then we have this one right here. Minus I root 3, perfect. And then the last one all the way over here. Let's see if we can do this all in one shot. Positive times a negative is going to be a negative. Root 3 times root 3 is just going to be a positive 3, right? So it's negative 3i squared. It's just plus 3, perfect. So that's gone. That's gone. Let's collect our pieces here. This is x squared. This is minus x minus 2x plus 3.
Plus 4.
Oh, plus 4.
Oh,
Ding, ding, ding.
that was so much work for that. I thought it was going to be more complicated. I have all the eyes and that's to be disappointed.
Technically multiplied by the
Oh,
conjugate,
just
right?
the
So yeah, it's going to be intertwined. So let's go long division over here. Let me do it quickly here. So x squared minus 2x plus 4 is dividing into 3x cubed minus 4x squared plus 8x plus 8.
Oh my gosh.
Oh, let's go. What multiplies x squared to give you a 3x cubed? Oh, just a 3x. 3x times x squared gives you 3x cubed. 3x times a minus 2 gives you a minus 6x squared. And 3x times 4 makes it 12x. And we subtract, or better yet, add the opposite. That's gone. 2x squared minus 4x plus 8. What number multiplies x squared to give you a 2x squared? Positive 2. 2 times x squared gives you 2x squared. 2 times negative 2, negative 4x. 2 times, oh, that's 8. And we're going to subtract. We better get a remainder of 0. I think we got it. This guy here said equal to 0, which is 3x plus 2 equals 0. Subtract 2 from both sides. Divide by 3. That is so awesome. Okay, so our final zeros. All zeros are negative 2/3, 1 minus I root 3. That's the way I like to write it. 1 plus I. You can do plus or minus as well. Absolutely. So final answer, and we went full circle. We are done. That was nifty.
That's gonna be like something on the test, right?
Of course. Of course I gotta torture you that way. All right, guys. Enjoy the rest of your day. Have a good one. See you guys on Wednesday.